All right, this section is really counterintuitive to me. That's why it kind of blows my mind away. I love this section because it's all about how we perceive that physical world out there. It's about sensation and perception, how we get information to our brain and what our brain does with it so we can manipulate the physical world through our psychological world. Okay, so sensation and perception, Unit 4, coming up right now. All right, we start off with sensation and perception, and here are the learning objectives for the first module. First of all, what is sensation and what is perception? Sensation is actually the idea of how we get that information. Some of the senses we pick up are going to be like energy waves, and some of it's going to be chemical. Perception is once that information gets into our brain, how does our brain interpret that? Okay, they are all one continuous process. They work together, but we're going to break them down into two sections here. So bottom-up processing and top-down processing. When we look at bottom-up, it's the analysis of the stimulus that starts with the sense receptors. So the receptors that sense the information and sends it up to our mind. The letter A is really a black blotch that's just broken down. It's a bunch of ink on a paper, it's a black blotch, and that's what we sense, and it comes up into our brain. But when it's up there, we top-down process. We can look at it. If you notice in this example, where it says, obviously, the cat, the H and the A are exactly the same. However, we easily perceive the H as being an H in the, and the A being the A being the A in cat. And it's because our brain immediately says, we recognize that, so we're going to recognize it this way, even though they are ambiguous. Here's another example you may have seen. This is an actual paragraph that's written down from Cambridge University, and you can easily read this, and it's all because of top-down processing. What that tells us about the way we read is we don't read letter by letter. We actually recognize words. Our brain says, this is a word, we expect this to be there, so it's going to see it for us. So this is really simple to read, and I'm sure you've seen stuff like this before. What we can pay attention to is really selective. Our brains are kind of serial processors in that sense. They want to pick out the important parts of our environment. There's tons and tons of information pouring into our system, but our brain needs to sort out the little piece that it thinks is the most important. This is what we call selective attention, paying attention to one thing. The cocktail party effect is an example of this. If you're in a crowded room, like in your classroom, and it's really noisy, like a lot of you are noisy in class, you will be able to attend to your conversation just fine because you've selected your attention on that, and the rest of it just sounds like mumbles, and you may not even be aware of it. But what's interesting, if someone from the other side of the room says your name, all of a sudden you pay attention. So your brain says your name is important. Okay, but we are only able to really focus on that one conversation. Another experiment, I know some of you have seen this because it's so crazy for those of us that haven't been exposed to this, is the experiment where they had 3 men in black shirts passing basketballs around, and you had to count them. And then in the middle of this, it was a video, and in the middle of it, there was a lady walked right through the middle with an umbrella. And the majority of people didn't even see the woman walking through with the umbrella. They were paying more attention, so their attention was focused on counting the passes. Why is this important? Well, it's important because, when you look at texting and driving, or you look at, the times that motorcycles are commonly getting into accidents where they are turning, because cars, when they are turning onto a road, they're looking for other cars. So that's where their attention is focused. They're not looking for motorcycles. And that's why motorcycles can be dangerous. It's not anybody doing anything wrong. It's the way our body works, but they're going to be in a lot of trouble for hitting the motorcyclist. Change blindness is another really weird thing. Dan Simons is a big researcher these days, and we'll look at some of the videos he shows on this. But what this cartoon here, this drawing depicts, is there's a man in gray hair that's giving directions to this person, and then some workers rudely walk through the middle with the board, and they actually switch the person that the man is giving the directions to, and he doesn't notice. And in fact, the majority of people don't notice. So what is it they do notice? You know, so the people that do notice, it may be just the certain thing that they're paying attention to. Maybe the color of the jacket or the color of the hair, the one thing that they do notice that they're paying attention to changes and they notice, but the majority don't. So senses are nature's gift. The physical world is out there. It's different than what we experience psychologically, but each organism has their own set of sensations. You know, and frogs feed on flying insects. A male silkworm can smell very little of the attractant, sex odor attracted from a female silkworm. And this is where pheromones were kind of discovered. Human beings, we're very sensitive to sounds, especially the sounds of the human voice, and in particular infants. So psychophysics is that study of the relationship between the physical world and our psychological experiment. So in the physical world, there's light. We perceive it as brightness and so on. There is sound. We perceive volume in our psychological world. There's pressure. We perceive weight. There's sugar. We perceive sweet. So the physical world exists out there, and then we interpret it. And we'll look into more of that in a second. But how much information needs to get there? It could be in response to an increase in physical energy. Perhaps there's enough physical energy out there. Say it's a light and it's so low that you can't even tell there's any light. So if you increase the light to the point where you see it, that would be the threshold that you need in order to perceive that there is light. The absolute thresholds, same thing for sound. You know, a quiet sound that you are not capable of hearing is below your threshold of hearing. Once you get to the point where there is enough input, sensory input, for you to perceive that sound, 50% of the time, we call this the absolute threshold. So that's kind of the minimum amount of stimulus necessary for you in order to perceive something. Below that, there is input, of course, that's coming into our brain that we are sensing, but we're not actually perceiving it. Below that time, we hear it 50% of the time. And this is our subliminal stimulus. When you hear about subliminal message and stuff, there was a big outcry about, movie theaters that were putting in, one frame and you can't really perceive it, but the information gets to you, so it makes you want to go buy. They put up, things like buy popcorn or buy Coke or other soft drinks, and it's actually false. It never really happened. But we've done it. It made the organizations actually ban the use of that kind of advertising because it felt like a kind of mind control. However, lots of research has showed that actually subliminal messages do not influence your buying behavior, but they do prime you somewhat. So, for example, if you are thirsty and you are primed with a subliminal message about a drink, it may prompt you to go buy the drink that you already wanted. But it has little effect as far as buying habits, so the mind control thing wasn't quite as serious as it sounded like. A difference threshold is measured if we look at these lights at the bottom. The absolute threshold is where we first perceive a light. So let's say we don't perceive this, or we perceive this light right here, and then we make it a little bit brighter. Can you perceive that it's brighter? Well, in the diagram you probably can, but this is just a representation. So the subject says, no, I can't tell there's a difference. No, I can't tell a difference on the next one. And yes, finally I can tell a difference. So with this observer's response, what we have here is a difference threshold. It means how much more of that energy needs to be produced or stimulus for us to tell there's a difference in that stimulus. And in this case, this is called a difference threshold, or the just noticeable difference. Okay, and we'll just discuss, the importance of these kinds of findings in class. However, the just noticeable difference makes a difference. If you're holding a 5-gram weight in one hand and we add 2 grams to that hand, you're probably going to notice there's a weight difference. But if you're weighing or holding a 2,000 kilogram car and we throw a 5-gram weight in that car, you're not going to notice any difference. So there's not a definite number. So Weber came up with this law, and basically it's based on a constant and it's based on like a percentage. So for example, the weight has to increase increase by 2% in order for you to notice a difference. Light needs to increase by 8%, tone by 3%. So if we had the 1,000 kilograms in our hand, we'd be very strong to hold it up. But in order to notice the difference, we would need 200 kilograms added to notice a difference. Hope my math is right. You get the right. It was supposed to be 2%. I don't know. It's close anyway. There's another theory that kind of counteracts the absolute threshold theory, is a signal detection theory, which basically says we are able to perceive things or notice them depending on our physical state of arousal, depending on our experience, depending on our motivations and our fatigue, which is really important when we look at things like air traffic controllers. We need them to be able to pay attention to things, and other professions where it's really important to be observant. You know, for example, you know, with expectations and motivation, a brand new parent will put their child in a new room or a different room than they're sleeping in, and they're so tired that a truck could drive through their living room and they have no perception of it. They sleep right through it. But their baby can just make a little cough sound or a little hacking sound, and immediately it wakes them up. So it depends on the person, the state they're in, of what they can detect, as opposed to an absolute threshold. Sensory adaptation is that idea that we're totally bombarded with sensations, but we tend to ignore them if it's a constant bombardment. For example, you put a Band-Aid on you, you feel it when you first put it on, but during the course of the day, you probably don't notice it. Look, figure your socks right now. You have probably, I hope you have socks on. I guess you're at home watching the video, so you may not have socks on. But if you have socks on at some point, you're not going to really notice them during the day. But if you say, think about your socks, you're going to notice how your feet are encased and trapped in those socks. But during the day, it's not important information for your brain to pay attention to because it's constant, so it weeds it out. Same thing that happens with smells. That's why sometimes we can't smell ourselves when other people notice that we're stinky, because it goes away. Okay, so it works in all the senses, including vision. This lady is a depiction of a research where they attach the projector to a contact lens. So when her eye moves, the projection goes to the retina in exactly the same place. And their vision is interrupted. They report incidences where the vision will appear, then it will disappear, it'll reappear in parts, and so on. So this is also like, hey, have you noticed the nose in front of your face? I bet you notice it now that I've mentioned it, but during the course of the day, you don't pay attention to it. Okay, all this is sensory adaptation. So what about influences on perception? Perceptual set makes a difference. Okay, that's a mental predisposition. Okay, that we have got you ready to see something. If we tell you to expect to see something, the Loch Ness Monster in this picture, maybe you've seen this famous picture of the Loch Ness Monster, people would see a picture of the Loch Ness Monster. However, we know that it's actually just a picture of a piece of driftwood that's gone by. The person taking the picture admitted it, and other people on the lake had seen this, so we know it's not true. We'll give you a lot of other examples of perceptual sets that may influence the way we see things. And we're sure we see these things, but it's just because we're expecting to, and our brain fools us. Context effects make a difference. These dogs, the one on the top looks larger, but because it looks farther away, we perceive it as being bigger, even though they're exactly the same size. Okay, we're going to stop it there on the first one, just to kind of keep these videos short, and we'll show you some of these effects that we've been talking about in class. Okay, all right, so bye for now. We'll see you next time for video 2.